In this video, we're going to talk about the rise of deep learning. By the mid-1990s, neural networks had started to fall out of favor in the machine learning community, even though they were still being used in connectionist psychological modeling. Although the first applications of convolutional networks, which we discuss in another video, had been successful at recognizing digits, they did not scale up well to more complex vision tasks. What changed? What turned around their fortunes and started the current deep learning boom? Well, many things happened, but one of the main factors that boosted the reputation of neural networks in machine learning was a series of stunning victories in important visual object recognition contests. And in particular, on the ImageNet Large-Scale Visual Recognition Challenge. ImageNet is a label index of photographs devised by computer scientist Fai Li, which consists of 14 million pictures belonging to 22,000 categories, along with human-created labels naming the object in the photos. The images were downloaded from the largest repository of pictures that humanity has ever had, namely the Internet, and the laborious labeling was done by legions of workers from all over the world through Amazon's Mechanical Turk service. The ImageNet challenge uses a subset of ImageNet, but still a sizable 1.2 million images, used to train machine learning algorithms, and a further 100,000 to assess them. The task is to correctly label the images. This is a dog, this is a chair, etc. The machine has to output the 5 categories it considers the most probable for a given picture. This is a very difficult task. To start with, you begin with a 2D image, but then have to make an inference about what is ultimately a 3D object, which, as we've already seen, is an ill-posed problem. So, suppose that the task is to identify a dog from a picture. Then the machine has to separate the dog pixels from the non-dog pixels, which can be anything from a wolf or a cat to a shadow in the background. A dog can look very different depending on the angle, posture, lighting conditions, whether it's at motion or at rest, and even worse, different dogs look very different. Compare a Pomeranian with a Husky or a Chihuahua and a Great Dane. Moreover, under some conditions, wolf pixels or even cat pixels, and why not, cloud pixels, might look a lot like a dog. Up to 2011, the best program in the ImageNet challenge had got 74% of the pictures right. The one in the previous year, 72%, and the one in the year before, 70%, and so on. It looks like machine learning was improving steadily but slowly. But in 2012, the winning entry got a surprising 85%. This winning algorithm in 2012 was different from the previous winner in that it used a different approach from the ones that were dominant at the moment. It was a convolutional neural network called AlexNet, after its creator, Alex then a graduate student in the University of Toronto, working under Geoffrey Hinton. Neural networks also started to excel at speech recognition and other tasks. Within a year of the win, a small company started by Hinton was acquired by Google for a lot of money. Hinton students became highly paid Google employees, and so the deep learning gold rush had started. What was it that enabled ConvNets that seemed to have reached a dead end in the 1990s to win on the ImageNet competition and subsequently to dominate computer vision? One element is the specific brain-inspired architecture, to be sure, but that was there from the beginning. There were also architectural advances, such as the use of the ReLU activation function and the development of techniques that allowed for better generalization beyond the training data. But what really turned their fortunes around was the availability of A, huge amounts of data for training, thanks to the Internet and the existence of Google and Amazon Turk, and of increases in computing power. As for the first aspect, although earlier networks had been trained on, at best, tens of thousands of data points, AlexNet and later models have been able to avail themselves of datasets comprised of tens of millions of images. As for the second, not only had computing power per unit of cost increased dramatically from the late 90s to the early 2010s, but the developers were able to use very fast parallel computer hardware based on GPUs, graphical processing units. A GPU, which may be known to you as a graphic card, is a single chip processor that is used for extensive graphical and mathematical applications and which frees up CPU cycles for other jobs, making computation much faster in general. These factors made deeper networks feasible, so that models with more than 100 hidden layers were able to be trained on millions of images in just a few days. These days, ConvNets are used everywhere, including all major search engines, all major social media apps. They can be applied to video and can be used in self-driving cars, to read lips or to classify body language. They can also diagnose breast and skin cancer from medical images, determine the stage of diabetic retinopathy, and many other medical applications. Moreover, other architectures such as transformers, as exemplified in the GPT series of natural language processors, are becoming more and more prominent. As I said, they are everywhere.